All right, good morning, guys. This is April the 8th and dividing radicals. So, dividing radicals is just like multiplying radicals. You have to have the same index, but you do not have to have the same radicand. So, we've remembered before from solving that if we have a square root or a radical of a fraction, we can square root the top and square root the bottom. So, we know that we can go this way. But I do want you guys to understand that we can go the other way as well. If you're given the square root of 4 and the square root of 25, or say, for instance, two numbers that don't simplify out nice and neat, like 160 and 5, you can go backwards and put them back into one radical that will make it a lot nicer and neater to simplify. You'll see that in just a second. So, dividing these coefficients like normal, and then using the quotient rule. The quotient rule is just saying that we can put these back under one big radical. So, for number 1, 12 and 2, we're just going to divide that out and get 6. And then we can make this 160 divided by 5 and put that all under one big radical. So that will equal out to 32. Then from 32, we just do our factor tree or type it into the calculator. And I probably could have done that a lot faster, but that's okay. So we've got a lot of 2's. We've got 2 of them, so that'll be a 4 on the outside, a 2 left on the inside. So that will be 24 square roots of 2. Okay? Pretty simple. You can do it that way with any sort of index as long as they are the same. So if you notice, all the problems on here are going to have the exact same index. For number 3, we'll do the same thing with radicals. We make them one big fraction bar. Okay? So dividing that out, that would just be x to the first power because we subtract those exponents. Y to the fourth power. And if you remember back from simplifying radicals, that is a 2 as our index. And anytime this number on the inside is smaller than the index, then you're finished with it. But anytime it's bigger, we need to simplify it a little more. So we can see that the x is going to be fine, but the y, we need to make that y squared. We take that 4, divide it by the 2, that will give us y squared on the outside, and that x stays on the inside. And that will be it. Understand that sometimes this works out nice and neat, like this one. You don't need to square root the top and square root the bottom when 48 divided by 16 is just 3, and there's nothing else you can do there. So I'll save you the heartache and go and then just tell you to do that one. For number 6, we have 40 and 27. Now, 40 and 27 can't be simplified like 48 and 16 can. So now is when you do need to do the cube root of 40 divided by the cube root of 27. So understand that it's sometimes going to work out nice and neat, sometimes it will not. But we do know that the cube root of 27 is just 3. Right? For 40, we can split that up into 4 and 10, 2 and 2, and 2 and 5. So that will be a 2 on the outside, and that will be a 5 on the inside, and you are completely finished. There's nothing else you can do there. So it is perfectly fine to simplify it out as long as we don't have a radical in the denominator, which we will learn about here. You cannot have a radical in the denominator at all. That's just not allowed. I'm not sure if we went over this with solving by square roots, but we're going to cover it now. So anytime there is a monomial in the denominator, in other words, there's only one term, like what we have here for number 9, what we need to do is multiply by the square root of 5, whatever that radical is, to the top and the bottom. Now, this value that I just multiplied by, the square root of 5 over itself just gives you 1. So I'm not changing the value of the problem. Right? I'm just multiplying it by 1, but I'm doing so in a way that once we solve this out, that will be 2. And anytime you multiply the square root of 5 times itself, or any number times itself, the radical sign goes away. Right? So the square root of 5, that would be the square root of 25, which is just 5, right? So 2 times 5 would just give you 10. So I'm okay if you just go ahead and write 2 times 5 in that next step. That is perfectly fine. Okay, so For the next one, for number 11, we'll do the same thing, but understand that we don't need to multiply by everything. We don't need to multiply by the 4 square roots of 7. We just need to multiply by the square root of 7. The 4 is perfectly fine to be underneath the radical. What is not, or underneath the denominator, or in the denominator, you know what I mean. But you can't have a radical there. So that will be 3 square roots of 70, 84. 3 square roots of 84 over 4 times 7. That will just cancel out when they're a square root. So then for 84, we'll simplify it out. 84 can be 21 and 4. That can be 3 and 7. 2 and 2. It's a square root. We're going to take a 2 out. And that 21 is going to stay on the inside. And we're left with over 28. That will be 6 square roots of 21 over 28. Now, if I gave you something like 10x divided by 4, you would know that you can still simplify 10 fourths, right? You would divide those both by 2, 5 halves, the x stays the same. It's the same concept here, right? We're not going to divide the 21 and the 28th because the 21 is inside a radical and the 28 is not. But we can divide the 6 and the 28. 6 and the 28 are both divisible by 2, so that will be 3 and 14. Okay? So then we move on to the ones where we have a binomial in the bottom, like 15, 16, 17, 18. This is one of the more challenging ones and something that you do need to know for Math 3. You will see this kind of stuff in Math 3. So we'll multiply by a conjugate. Maybe, hopefully you guys will remember difference of squares, right? Where when we multiplied these out, that middle term actually cancels out, right? So we're left without that middle term, and it's just x squared equals 20 or minus 25. Same concept here. We're going to multiply by something, but instead of just multiplying by the square root of 2, that will not get rid of the radical. If you don't believe me, try it. You need to multiply by the conjugate. And that conjugate is the opposite, the exact same thing, but the opposite sign when it's a binomial. It's the exact same thing, but it's an opposite sign. So we're going to distribute that 4, and that will be 16 minus 4 square root of 2. And then we will have 16 minus 4 square root of 2 plus 4 square root of 2 minus 2. Again, so those right there will cancel out. And those middle terms will cancel out as well. So we have 16 minus 4 square root of 2 all over 16 minus 2. Those middle terms right there will cancel each other out, and that will just leave us with 14. So 16 minus 4 square root of 2 over 14. Now from there, all of those coefficients, we can divide them all by 2. So that will be 8 minus 2 square root of 2 all over 7. And that is completely simplified there. There's nothing else you can do for that one. Now, these get a little more tricky. If you want to try them, you can, but I'm not going to require you to do so. I don't believe you're going to see anything this crazy in Math 3. As long as you understand that you're multiplying by the conjugate, you're good. So I'm going to do this one with you as well, just so that you can see what's going on. Again, I'm more concerned with you comprehending the material than I am you finishing every single one of these problems. So that will give us, when we multiply out, that will give us a 12 plus 2 square roots of 5 up top. Now on the bottom, we have 36, and we know that these are going to cancel out, right? That's going to give us a negative 6 square roots of 5 and a positive 6 square roots of 5. So I'm perfectly fine if you just multiply the first two, 6 times 6, and the last two, negative square root of 5 plus square root of 5, which will be minus 5. So that gives you 12 plus 2 square roots of 5 over 31, and that will be it. That will be completely simplified there. So on your homework, I will scroll down and again tell you to not worry about 17 and 18. You can still do them if you want to, but as long as you have a couple of practice problems on rationalizing the denominator when it's a binomial and a monomial, you will be great. Thank you guys so much. If you got any questions, always feel free to shoot me an email. I'd love to hear from you guys. And